Okay, looking at some of the more frequently missed questions, 4 is actually not a very good question. It's not clear which is not a correct conclusion and reason based on the diagram. It's not clear if you're supposed to look at just what's given here as these sides being congruent and so forth, or if you can draw conclusions based on what you know about transversals and parallels and vertical angles and so forth. Because actually all 4 of these, the textbook lists D as the correct answer, but this you can also prove that DEC and AEB are congruent by the side angle side theorem. So let's just not worry about the problem itself, but let's just use it as a review of using some of the theorems and properties we've learned. Let's look at what we know as far as showing that this is congruent by the side angle side theorem. We know that these 2 angles are congruent by the vertical angle theorem. Okay, and we also know that we see right angles here, so these opposite sides AB and DC are parallel and AD and BC are parallel, so we have transversals here. These diagonals of the rectangle are transversals. So this angle here is congruent to this angle here. Looking at this transversal, and then we have this angle here congruent to this angle here, and we also have we could go further and say, looking at these as parallel AB and BC, this angle here is, let's put it this way, this angle here is parallel to this, or congruent to this angle here. And this angle here congruent to this angle here. So then, these 2 angles, by angle, side, angle, we could say that these 2 triangles are congruent. All right? And that means that, corresponding parts are congruent, which would mean that, let's see here, this would come over here on this one. So we could say that, this side is congruent to this side, and this side congruent to this side. And now we can say by side angle side that these 2 triangles are congruent. So that's just not a really good question, but I hope you can see how we use some of our properties and postulates and so forth, our theorems and postulates. All right, looking at number 6, given that R is the midpoint of segment SP and segment TM, and segment TS is parallel to PM, which congruence postulate or theorem could not be used to prove that those triangles are congruent, which could not be used? So let's go ahead and just, you can't mark on the test, but you could copy this, and it may help to mark what's given. So we know that R is the midpoint of SP and TM. So that means that, PR is congruent to SR, and TR is congruent to MR. And then these are parallel, so we know that this angle here is congruent to this angle here, and this angle here is congruent to this angle here. So number 6, we're looking at, let's see, what's the answer to number 6? A. So number 6 is A. All right, that's the only one that we can't, and that's pretty easy, maybe without even going through all that work. We don't know anything about all 3 sides. We only know something about 2 pairs of sides, so we cannot use the side, side, side postulate to prove those triangles are congruent. But we could use the other 3. All right, we also know that this angle here is congruent to this angle here. So we could use side, angle, angle, and angle, angle, side. So that's 4 and 6. Let's look real quick at 7 and see what that's all about. The base angle, I think what people may have had trouble here is just with the vocabulary. The base angle of an isosceles triangle measures 42.5. So base angles of an isosceles triangle are congruent, so both of them are 42.5. What is the measure of the vertex angle? The vertex angle is where the two congruent sides meet, the angle formed by the two congruent sides. So we just need to take, 180 minus the sum of 42.5 plus 42.5, which is what, 85? So we take 85 away from 180, and we have 95. Okay, so that would be answer choice D. So I'm going to stop there for those three.